And the paradigm, the algorithm design paradigm that is used here is what is called divide and conquer. So, some of you might have seen divide and conquer in your earlier CS course. Basically what the idea is that given a certain problem, to solve the problem you first divide the problem up into parts, yeah, 2 or more parts. Then you recursively solve those sub problems, so recursively solve the problems on those parts, right. So, that is what is called the conquer step. So, recursively solve the problems on those parts. When I say recursively solve, how do you solve the problems on those parts? By once again dividing them into smaller parts and solving the problems on those smaller parts and so on. So, use the same algorithm to solve the problem on the smaller pieces, and once you have the solutions for the smaller pieces, you need to somehow combine the result to get the solution for the original problem. So, that is what is called the combine step, and we will see this through an algorithm for the sorting problem. We are going to look at what is called the merge sort algorithm, right. Some of you again must have seen this before. If you have seen it, it is okay, because we will see at least a different way of analyzing the algorithm. So, what is sorting? Basically you are given n numbers which you need to put in increasing order, let us say, okay. And let us say S is the set of n numbers. What we do is we would split n into 2 sets S1 and S2, 2 sequences S1 and S2. So, this is the divide step, and the split would be such that S1 and S2 would contain roughly half of the elements of S, okay. Now, recall this should look very similar to you to another algorithm, the quicksort algorithm, right. There also we did a division at the very first step, right, but how was the division done there? It was not equal, right. So, in the divide step there we were dividing the problem into 2 sub problems, but those 2 sub problems were not equal in size. One could be smaller than the other, right. But here we would make sure that we divide it into 2 equal sub problems. Equal by mean the number of elements in the 2 sub problems are equal. So, if S1 contains the first, let us say n by 2 elements, n by 2 ceiling, then S2 contains n by 2 floor elements. What do I mean by first n by 2 elements? Not the first n by 2 in a sorted order, because I do not know what the sorted order is. S is just some arbitrary collection, some list, some sequence. I just take the first n by 2, call that S1, the next n by 2, call that S2, right. Now, conquer step is that I would sort these 2 sequences, I would sort S1, I would sort S2. Yeah. So, recursively I am solving the same problem, and then once S1 and S2 are already sorted, I have to combine. I wanted a sorted sequence for S. I have S1 as one sorted sequence, I have S2 as another sorted sequence, but what is S? S is not, so if I say what is the sorted sequence corresponding to S, it is not just S1 followed by S2, no guarantee that that is sorted, right. So, I need to what is called merge S1 and S2 into one sorted sequence. That is called the merge step or the combine step here. Okay. Now, who can tell me? So, in the case of quicksort, the divide step was I take an element and I compare, that is the pivot element, and I compare every element against this element. Yeah. We had this procedure called partition which was helping us do that, right. That was a more involved procedure because we were trying to do it in place, right. So, we were kind of just swapping elements till we got 2 sequences, right, one containing all elements less than the pivot and another containing all elements greater than or equal to the pivot, right. That was the division step. How much time did we spend in division there? Order n, because we had to compare every element against the pivot. How much time do we spend in the division step here? Constant time, right, because we are just saying if it is an array we just say okay, this is S1, this is S2, we are not copying anything from anywhere to anywhere. That is one difference, right. We will come back to the conquer thing. Let us look at combine. In the case of quicksort, we are doing the same thing, right. We partitioned, then we said okay, we will quicksort one part, we will quicksort the other part, right, and then we will combine. Did we have to do combine there? No, because we could just take the first sorted sequence, put the pivot element and then take the second sorted sequence, and that would be the sorted sequence for the entire thing, right. So, how much time was combining there taking? Constant time. Here combining will not take constant time. Here we have two sequences and we have to combine them. We will see that it will take order n time, right. This is also called the merge step, and the name merge sort is deriving from this step, right. So, everyone understands what the algorithm is. So, for instance, this could be this is a pseudo code for the algorithm. I give you an array A, P and R identify the part of the array, the lower and the upper bound, which needs to be sorted, which needs to be merge sorted, right. So, if P is less than R, only then we need to do something. P is the lower and R is the upper index. So, Q is the midpoint, P plus R by 2, yeah. So, I am going to, so this is the division step, these two are the recursive solving, the conquer steps. I am saying from P to Q sort the first part of the array, from Q plus 1 to R sort the second half of the array, sort using the same merge sort procedure, right. And once you have this part and this part sorted, you have to combine. For that I have another procedure called merge, right, to which I specify P, Q and R, right. So, this procedure merge, the definition is the following. Okay, this is what it is doing, but what is the definition of merge? It is going to take the two sequences, one sequence is from P to Q, the other is from Q plus 1 to R, and merge them and make one sorted sequence which will sit in P through R, yeah, that is merge. And how does merge proceed? That is essentially what the merge algorithm is doing, and we are going to see examples of it. So, do not worry, but let us just read through this and you will understand a little bit of what merge is going to do. It is going to take the smallest of the two topmost elements of these two sequences. So, what do I mean the smallest of the two topmost elements? What is the topmost element of this sequence? The first element, topmost of the first element, which is P, or the element at location P, A of P. And the topmost element of this sequence is A of Q plus 1. I am going to take the smaller of these two, right, and put it into the resulting sequence, whichever is the smaller, right, when I have to merge. So, if I have to merge these two sequences, which will be the smallest element of these two sequences? It will be the smallest of this and these two, the smallest of these two numbers. I do not have to worry about any other numbers, because this is already sorted and this is already sorted in increasing order. So, I take the smaller of these two and that gives me the first element of my resulting sequence, right, and in this manner I can continue building up the resulting sequence, and we will see how that is done.